So look up, please. Let's look at a second example, which is this one here. So in this question here, of course, this is a second order differential equation, but the difference here between this one and the first one is that for this one, you can see these things. These are conditions. With these conditions, you can find the value of what? The constants. That's the concept there. You can find the value of the constants given these. Right, so how do we solve this question? Let's take them from the very beginning. So first things first, we'll ignore these conditions for the meantime. Ignore these conditions. Start with this one first. When it comes to solving a second order differential equation, we said first step is to put y as equal to what there? Exponential mx. This is always your first step in solving second order differential equation. From this, you are expected to find the value of what there? Y prime, and what again there? Y prime prime. We know that y prime is the same thing as dy dx. So we can say y prime, same as dy dx, is equal to, when we differentiated this from our previous example, right? To differentiate this, simply differentiate mx. It gives you what there? M. It becomes m attached to this exponential mx. That's y prime. Let's get y prime prime. Y prime prime, this is same as the squared y over the x squared is equal to differentiate this, in which the tax there is simple. Differentiate mx, it gives you m times all of this. So m times m gives you m squared exponential mx. So you have this. All right, so y equal to mx, y prime equal to m exponential mx, y prime prime equal to m squared exponential mx. These are constants, always constants. Next up, let's do a substitution. So substituting into the given differential equation. So I have 2. I'm having 2 into the squared y dx squared. This value is same thing as y prime prime, which is what there? M squared exponential mx plus 5 into dy dx. Same thing as y prime, which is what there? M exponential mx plus 3, so plus 3 into y is exponential mx equal to 0. So this is equal to 0. We have this. All right, expand this. What do you have here? This and this. 2m squared exponential mx plus this multiplies this 5m exponential mx plus this multiplies this 3 exponential mx. It's equal to 0. So I have this. At this juncture, the next task is to do what there? Factorize the value of what? Exponential x. So I factorize exponential x, and exponential x. Please, in your note, don't cancel though. Don't cancel. Just factorize this. What do you have here? 2m squared here plus 5m plus what do you have here? 3 all into exponential mx is equal to what there? 0. So I have this. Right, so we have this. What next there? Pick up this one here and equate to 0. So pick up the auxiliary quadratic equation, 2m squared plus 5m plus 3. Pick it up and equate to what there? 0. If I have this, what's the next to do there? Please point this with the calculator. Solve this. What do you have? M1 is equal to minus 1 and M2 it's equal to minus 3 over 2. So we have this. So these are the answer. So this is a quadratic equation. Solve this, you have this value here, okay? I'll leave a link on how to solve quadratic equation using calculator in the video description. All right, so check the video description for the link on how to solve quadratic equation using a calculator. All right. Anyways, let's proceed. So from here, at this point here, my next task is to get the two linearly the two linearly independent solutions. The first question you ask yourself, what kind of roots do you have here? What we have here, they're actually what? They're distinct roots. If they are distinct roots, what does it mean? It means that they are different. And what would the independent solution look like? We said you have y1 as equal to exponential m1x. What's m1 there? Minus 1. So m1x becomes what there? Minus 1 times x, which gives you what there? Minus x. So minus x. We said this in the first class, the first lesson. Also, y2 is equal to exponential, the value of m2, attach x to it. So it becomes what there? Minus 3 over 2, attach x. So this becomes the value of what there? Y2. I have this. So I have y1, I have y2. What about the general solution? The general solution is given by, how do you get general solution? We said general solution y, a function in terms of x, will be equal to what there? C1. So it becomes C1 multiplying the value of y1, which is this C1 exponential minus x plus C2 multiplying the value of y2. That's exponential minus 3 over 2x. All right, so this becomes the general solution of the second order differential equation. Now, with this one here, whenever you're given this stuff here, this one's here, you're expected to find the value of what? The constant C1 and C2. All right? So let's find, let's get C1 using, get C1 and C2 using the conditions. What conditions? The first in there, y of 0 is equal to 3 and y prime of 0 equal to what there? Negative 4. All right, so how do you apply them? So please look up. How do you apply them? Please look up. Let me just use here. Do I even need this part? Nope, I don't need this. I don't need this part. No, I don't. So don't worry, let me take this one off too. All right, so look up, look up, look up, look up. Let's start with the first one there. Y of 0 equal to 3. So the first one there, at y of 0 equal to 3. What do we have? What this simply means is that at, what you have in the bracket is x. At x equal to, this one here, 0, y equal to what there? 3. That's what this means. So at x equal to 0, y is 3. That's what it means. So I'll look for the y equation. Which of these is the y equation? This one here. This is the y equation. Let me call this asterisk. Let me call this equation 1. Let me substitute that into equation 1. So substitute into equation 1. What do I have there? That means when x is 0, y is 3. So I'll replace this as what there? 3. This becomes 3. So I'll have that 3, that's y of x. 3 is equal to, wherever I see x, this sign here, I'll put 0. C1 exponential minus 0. X is 0. So I have C1 exponential minus 0, let's keep it that way there, plus C2 exponential minus 3 over 2 minus 3 over 2 times x. What's x there? 0 times x. X is 0. Okay, so at this point here, let's not stress ourselves. This will give you 3 is equal to C1 C1, this is exponential minus 0. Exponential minus 0 is still the same thing as what there? Exponential 0. Right? Minus 0 is same thing as plus 0. So this now becomes exponential 0. If you punch exponential 0, what's the value? You can punch it, that gives you 1. So this one here gives you 1 plus, for this gives you C2. Now looking at this one too, this is exponential minus 3 over 2 times 0. First things first, minus 3 over 2 times 0 gives you what there? 0. Exponential 0 gives you what there? 1. So I'm having 1 here. Let's multiply this. What do you have there? 3 is equal to what there? C1 plus C2. Call this your, let's call this I. Let's call it I. Okay, there's 1, there's I. I'm done with this. In other words, I have now successfully substituted the first condition. What do I need next? I need for second condition. Second condition talks about what there? Y prime. When you see Y prime, what comes to mind? Differentiation. Differentiation, differentiating. So what will Y prime be? Y prime will be equal to, for Y prime, simply differentiate the value of Y. You have Y prime. So differentiate this one here. If I differentiate this, what do I get? How do you differentiate this one? First is first. Here's your first term, which is this. Differentiate this term, what do you get? This is a constant. Keep it pending. Differentiate exponential minus x. We've said the shortcut is to differentiate the power. If I differentiate minus x, what do I get there? Minus 1. Use minus 1 to multiply everything here. It gives you what there? Minus C1 exponential minus x. That's how you do that. Next up, plus. Let's now differentiate this term here. How do you differentiate this? Again, this is a constant. Don't bother. Focus on this. To differentiate the exponential minus 3 over 2x, the concept is to differentiate this part here. Differentiate minus 3 over 2x with respect to x. What do you get there? Minus 3 over 2. Attach minus 3 over 2 to this value. What do you get there? Minus 3 over 2, what there? C2 exponential minus 3 over 2x. That's all. So differentiate the power, bring it down. We have this. So this is what we have. Now let's bring in the condition at y prime of 0 equal to minus 4. What are we saying? We're saying that at x equal to 0, that y prime is equal to minus 4. That's what we're saying. Let's bring in the condition. So this value is minus 4. So minus 4 is equal to, whenever I say x here, I'll put 0. So it becomes negative C1 exponential minus x minus 0 minus 3 over 2 C2 exponential minus 3 over 2x. X is 0. So you have this. Whenever I say x, put 0. That's all. Without wasting much time, what we have here will be minus 4. It's equal to minus C1. We know that, just as we had here, exponential minus 0 gives you 1 minus 3 over 2, this one here, C2. Again, just as we had here, exponential minus 3 times 0 gives you what there? 1. This gives you 1. You have this. Alright, so what do I have here? I have that minus 4. It's equal to C1 minus C1 times 1 gives you minus C1 minus 3 over 2 C2. Of course, times 1 is itself. We'll call this equation II. So we now have I and II. To get the value of C1 and C2, we'll solve I and II simultaneously. All right, solve I and II simultaneously. All right, let's do that. What do we get? For the first one there, hope it's okay if I reverse this. By that I mean I'll write this one here equal to 3 instead. All right. So I'll write this one first as being equal to 3. So I'm saying this, I can write that C1 plus C2 is equal to 3. It is the same thing as this one here. For this one too, I can write that negative C1, okay. This one here, negative 3 over 2 C2, it's equal to minus 4. All right, let's solve. This is equation 1, or I. This is I. This is II. Let's solve I and II simultaneously. So how do we solve it? What do we do at this juncture? Because this is now simultaneous equation, which we've done since your GS3. So how do we solve it? What do we do? Nah, come on, man. This is not GS3 now. What do I do? What do I do? It's elimination method. What do I do? It's not like, huh? Just add them up. That's all. Right? That's why you did this before now. At this point, we can clearly see that we can eliminate this one here. How? Don't subtract them. If you subtract them, you'll be having C1 minus C1. And that will now give you C1 minus is plus. You'll now be having C1 plus C1. That gives you what there? 2C1. That will not eliminate. It will not work that way. But if I try to add them, so let me add them up now. Let's add them. What do you have there? Let me try to add them. What do I get? First things first, I have C1 plus minus. Plus minus gives you what there? Minus. To become C1 minus C1. That gives you what there? 0. It's off. That's it. Next up, let's take this and this. Again, we are adding. So plus minus is what there? Minus. Right, so it becomes C2 minus 3 over 2 C2. Now to solve this, all you have to do is this. Just punch, the coefficient here is 1. Just punch 1 minus 3 over 2. We've said plus minus is minus, so minus 3 over 2. What do you have here? Punch this, what do you have? Huh? Minus 1 over 2. So what I have there becomes minus 1 over 2 attached C2 is equal to 4. This becomes 3 plus minus 4. Plus minus is minus. So 3 minus 4 gives you what there? Minus 1. So we have this. The first thing you want to observe is I have minus on both sides. And it can cancel out. So this minus will cancel this minus. So I have this. How do you get C2 here? What do you do? Cross multiply or multiply by 2. So whichever one suits you. No problems. So we have 1 over 2. Or 1 times C2 is C2 all over 2 is equal to what there? 1. Let's get C2. That's not a problem. Of course, this is all over 1. So cross multiply 1 times C2, it's equal to 2 times 1, 2. We've got the value for C2. Let's put C2 into equation I. From I, we have that C1 plus C2 is equal to 3. Hence, we can say that C1 is equal to 3. Move C2 over here becomes what there? Minus C2. Now I'm bringing the value of C2. C2 is 2. So you can say that C1 is equal to 3 minus what's C2 there? 2. So C1 is equal to 3 minus 2. That's what there? 1. So we have this. With this, we've now got the value of what there? C1 and what there? C2. All right. Now at this point, we can now finally get the general solution of the equation. I want to clean this part, please. Please go back to equation 1. Please go back to equation 1, where we had the value of what? Y of x. From equation 1, we said that y of x is equal to, what's the value again? C1 exponential minus x plus C2 minus 3 over 2x. Let's put the value of C1 and C2. So substitute C1 and C2. What do we have there? We have that y of x is equal to C1, which is 1, that's 1, times exponential minus x plus C2, 2, this one is 2 times exponential minus 3 over 2x. So if I do that, what do I get there? I will have that y of x is equal to 1 times this is itself. That gives you exponential minus x plus 2 times this gives you what there? 2 exponential minus 3 over 2x. So this, ladies and gentlemen, becomes the solution to the second order differential equation. Okay, I have this. All right, so this becomes the answer to this. So this is how you solve the question. All right, so see the way you get your linearly independent solution. From there, you now get your general solution. They're using conditions. You now get the value of what there, C1 and C2, and then you solve this. So this is the answer to the question, please. Let's try yet another example.
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description. Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.